Rust lifetimes. Lifetimes are the last piece of Rust's ownership system. They answer one question: how long does this reference live? The compiler uses lifetimes to make sure every reference is always valid. No dangling pointers. No use after free bugs. Most of the time, lifetimes are invisible, but sometimes you need to help the compiler. Here is the problem lifetimes solve. This function takes two string references and returns one of them. The compiler does not know which input the return value comes from. It could be S1 or S2. Without that information, the compiler cannot verify the returned reference is valid. That is why it asks for lifetime annotations. Lifetime annotations tell the compiler how reference lifetimes relate to each other. The TICA syntax means the returned reference lives at least as long as the shorter of the two inputs. Annotations do not change how long references live. They describe the relationship so the compiler can check your code. The compiler knows that the result might reference either string, so it prevents you from using the result after the shorter-lived string is dropped. If you try to use the result outside the inner scope, the compiler catches the error. This is how Rust prevents dangling references at compile time. Most of the time, you do not need to write lifetime annotations. Rust has 3 elision rules that figure them out automatically. Rule 1. Each reference parameter gets its own lifetime. Rule 2. If there is exactly one input lifetime, it is assigned to all outputs. Rule 3. If one parameter is self, its lifetime goes to outputs. Functions with one reference input and one reference output work without annotations because of Rule 2. Methods that return references work because of Rule 3. Only when the compiler cannot figure it out after all 3 rules does it ask you to add annotations. That is when you see the missing lifetime specifier error. When a struct holds a reference, it needs a lifetime annotation. The TICA on the struct means the instance cannot outlive the reference it holds. If the reference data is dropped, the struct becomes invalid and the compiler prevents you from using it. This keeps structs safe from dangling references. Methods on structs with lifetimes follow the same rules. Rule 3 usually handles things because self has a lifetime. The compiler assigns self's lifetime to the output. You can also have methods that take additional references and return own values like string, which need no lifetime annotations at all. Sometimes a struct holds references with different lifetimes. You can use multiple lifetime parameters like tick A and tick B. This is rare in practice. Most structs need only one lifetime. Use multiple lifetimes only when the references truly have independent lifetimes. The static lifetime means the data lives for the entire program. String literals have the static lifetime because they are stored in the program's binary. Do not use static to silence the compiler. It usually hides a design problem. Use static only when the data truly lives forever, like string literals. A common pattern is returning the longer of 2 strings. Both inputs share the same lifetime annotation. Another pattern is finding something in a string where only the text input needs the lifetime, not the search marker. The output comes from text, so only text needs the annotation. You can combine lifetimes with generic types. The lifetime and the generic are both declared in the angle brackets. They serve different purposes. The lifetime relates to references. The generic type is for unrelated parameters. This pattern appears in many Rust standard library functions. Enums can also hold references with lifetimes. A token enum might have a word variant that borrows from the input string. The tokens cannot outlive the input. This pattern is common in parsers and lexers where you split input text into meaningful pieces without copying the data. A common mistake is trying to return a reference to a local variable. No lifetime annotation can fix this because the data is dropped when the function returns. The fix is to return an owned value like string instead of a reference. Return owned values when the data is created inside the function. Remember that annotations are descriptive, not prescriptive. They describe how long references already live. They do not change anything. Also, do not add unnecessary annotations. If the elision rules handle it, let them. Only add lifetime annotations when the compiler asks for them. When lifetimes feel hard, consider alternatives. Return an own string instead of a reference. Use string instead of a string slice in structs. Use RC or ARC for shared ownership when references get complicated. Start with own values and optimize to references later if needed. Here is a summary of lifetime concepts. Tika names a lifetime. Function lifetimes link input and output references. Struct lifetimes mean the struct holds a reference. Static means it lives forever. The three elision rules handle most cases automatically, so you rarely need to write annotations. In the next video, we will learn closures and iterators. Closures are anonymous functions you can pass around. Iterators let you process collections in a clean, efficient way. Together, they replace most loops with short, readable code. These are two features that make Rust feel like a modern language. If you like this video, hit the like button and subscribe for more tutorials.